Good morning, students. Today I'm going to discuss another some topic in the chapter Biotechnology. Today I will start with electrophoresis. Now, what is electrophoresis? Electrophoresis is a technique by which we separate various molecules, say protein, DNA, RNA, etc. with the help of electricity. Now, there are two kinds of electrophoresis which we do today. One is page, other one is age. Page stands for polyacrylamide gel electrophoresis. Whereas age stands for agarose gel electrophoresis. Now, this page is used for separating proteins. This age is used for separating nucleic acids. Now let us see how these two processes are done in here. Sorry. To begin with, I will start with page. Now in page, what we do is we take a gel which is made up of polyacrylamide and put a setup like this. These are some of the oils, means कुआ होता है, or it is connected with somewhere. Now, what happens? The proteins to be separated. Say for example, is a size of amino acids, say 600 amino acids. Now first thing is, why should we separate protein or why should we separate DNA or RNA? We separate it so that we can verify or we can analyze that particular DNA or protein more easily, because the smaller the easier. The bigger, the tougher. So in such a manner, we do this electrophoresis. Now what we do is, the required protein which are to be separated, we put into this well. This is particularly a gel which is made up of polyacrylamide. Now what we do is, when we put these proteins inside it and switch on the current, what happens? Protein starts moving towards the other end on the basis of its molecular size and ionic configuration. Say the larger the protein, the lesser it will travel. The smaller the protein, it will travel more. And after traveling, it forms band like this. After the traveling, it forms band like this. And then we extract this protein for our analysis purpose. Now, with the age, that is agarose gel electrophoresis, we do the same thing, but here we don't use properly acrylamide, rather we use agarose gel. Now, agarose gel or polyacrylamide gel is a kind of thing which do have some pores in between. The polyacrylamide gel forming the pore is suitable for protein separation, whereas agarose gel forming the pores are suitable for DNA or RNA separation. We do the same thing. That is, we have separated these things the same way here also, whether or from charge or molecular size, DNA or RNA will also be separated when we plug in and we put some current on it. Then we extract this gel and then we extract that particular DNA. Now there are two differences. Another difference is between age and page. In page, we can directly see the protein because structurally protein is somewhat more prominent than that of DNA or RNA. For agarose gel or for nucleic acid, we need UV light or UV torch for looking into these objects, that is nucleic acids, DNA or RNA. But in case of page, we don't need that. The protein itself takes some color and we can directly see these bands. Whereas in case of DNA or RNA, we cannot see these bands. If you need to see these bands, separated DNA or RNA, we need to use UV light. We need to use UV light. Sorry. Now, what we do further? Once we have done this, what we do further actually? Now we can do something, some processes. Now what are these processes? So it was all started by a person called E.M. Southern, who developed a technique called Southern hybridization. Usually it is named after him only, where actually DNA and DNA hybridization process is done. Now after that process, when he discovered it, some other processes are also discovered or came forward, which are actually Northern hybridization, which actually do RNA hybridization, and Western blotting or Western hybridization, for protein hybridization. Now this all this process all started with this person, that is E.M. Southern. He first discovered two hybrid DNA and DNA. Then we named the technique after him, that is Southern hybridization, and we continue with the following, like Northern for RNA, Western for protein. That's all. Now let us see what is done in Southern hybridization. Now as I told you people already that it is a technique by which DNA hybridization is formed. Now it all starts with, थोड़ी देर पहले मैंने जो बताया था आप लोगों को, क्या बताया था about age, that is agarose gel electrophoresis. Firstly, it starts with age, agarose gel electrophoresis. Then we extract this DNA and put it into a beaker. This gel is placed inside a beaker. Now inside this beaker we use some buffer solution and we put some absorbable pages like filter paper we put here, and above this gel what we put is a membrane which is usually made up of nitrocellulose membrane. We use another thing is DNA probe. Now what is DNA probe? DNA probes are small stretches of DNA. More or like it is like a primer. But DNA probe is artificially made some made some DNA which are supposed to be complementary to some of the DNA sequence which is found in every single DNA molecule found. Now it is not like primer. Probe is something which is very much specialized or specific for few sequences only. Now what we do is we put this probe into this nitrocellulose membrane and then we put this buffer solution. Now we know there is an activity which is, जब क्या होता है कि हम लोग कोई भी ब्लॉटिंग पेपर को पानी में रखते हैं, ये सोक कर लेता है. सो इस सोकिंग को यहाँ पे भी सोक होता है और ये पानी जो होता है ये बफर सोल्यूशन होता है, ये ऊपर की तरफ जाता है बाय एन एक्शन कॉल्ड कैपिलरी एक्शन. नो ये जब ऊपर की तरफ जाता है ये मेम्ब्रेन में पहले से क्या रहता है, द डीएनए प्रोब. अब क्या होता है कि ये जो डीएनए यहाँ पे लगा हुआ है हमारे जेल में जो कि एगारोस जेल है, वो यहाँ से उड़ के ये मेम्ब्रेन में अटक जाता है एंड इट गेट्स बाइंड विद द डीएनए प्रोब इन सम प्लेसेस इन द डीएनए एंड देन वी पिक इट अप, वी bring it out the nitrocellulose membrane, then we bake it around 80 degrees Celsius in an incubator, and then we can just pull out this DNS. We pull out this DNS and then we can go for DNA analysis. Now this is known as DNA hybridization. Why perhaps? Because here the DNA probe and our extracted DNA gets binded with each other. That is hybrid. A DNA molecule which we extracted and a DNA molecule which we provided, they hybrid, मतलब mix हो गए, bind कर लिया, and then we can put into them into analysis. Now what we do for, हम लोग ये करते क्यों नहीं है साउदर्न हाइब्रिडाइजेशन? हम लोग साउदर्न हाइब्रिडाइजेशन इसलिए करते हैं, कभी कभार ऐसा होता है कि डीएनए मॉलिक्यूल इतना बड़ा है और उसको एक्सट्रैक्ट करने का कोई सोर्स भी नहीं है कि प्रॉपरली एक्सट्रैक्ट हो जाए, कि हर एक पार्ट में एक्सट्रैक्ट हो जाए, थोड़े थोड़े पार्ट्स में एक्सट्रैक्ट हो जाए, ऐसा होता नहीं है. सो उसलिए क्या करते हैं हम लोग कि एक बहुत बड़ा डीएनए मॉलिक्यूल है, डीएनए मॉलिक्यूल भी सच ए बिग दैट इफ यू अनवाइंड इट वी कैन रीच डाउन मून फ्रॉम द अर्थ. इतना लंबा होता है, तो उसको अगर हम लोग पार्ट वाइज करके उसको एक्सट्रैक्ट करते हैं एंड देन वी कैन फाइंड आउट दिस स्मॉल फ्रेगमेंट एनालिसिस कर सकते हैं, तो वो हम लोगों के लिए बेहतर होता है. सो दैट पर्पस वी डू साउदर्न हाइब्रिडाइजेशन. And why it is called hybridization, or sometimes it is also called blotting, southern blotting. Why blotting? Because this blotting paper जो होता है उसके वजह से ये blotting मतलब ये absorb होता है due to capillary action and जाके यहाँ पे लगता है. So we call it as southern hybridization, and we know now that southern hybridization is a technique which is used for DNA hybridization. Now let us see what happens with the northern hybridization, we do it in the same way, but यहाँ पे DNA नहीं होता, यहाँ पे we use RNA, and यहाँ पे हम लोग RNA primer ही use करते हैं. Yes, we use RNA primers only, and then RNA and RNA is hybrided. Now RNA को क्यों करें? Because there are some organisms which don't have DNA as their genetic material. Rather, they do carry RNA as their genetic material. To analyze those organisms, say for example, the coronavirus is having this RNA genetic material as a genetic material, and we can extract it and you can analyze it. And this is how, as I told you, we have analyzed this with PCR. We can come out with the result that whether the patient or the person is corona positive or not. I already told you people. Now, before doing so, what we have done actually, we did this. We did northern hybridization. We have extracted and we have taken and we have analyzed the total RNA fragment. And then we have done this. Then we can go for PCR to, as we know now, the strand of that RNA sequence. Now, these are the few techniques. To continue with, today, I will tell you about a unique enzyme. Now, DNA polymerase is an enzyme which can make mRNA, or sorry, RNA polymerase is an enzyme which can actually make mRNA from DNA. Now, this is the normal thing we know in transcription and translation. We produced DNA, mRNA from DNA, and then from mRNA we have synthesized protein. But there is an enzyme which is known as reverse transcriptase. Now, what is reverse transcriptase? It is an enzyme which can do wonder. What wonder it can do? It can produce DNA from mRNA or RNA. That is, it is reverse to normal transcription and translation. What it can do, we can find RNA से हम लोग DNA निकाल सकते हैं. So इससे हम लोग क्या क्या कर सकते हैं? What we can do? Suppose we don't know the sequences for any protein, say protein which is producing human growth hormone. Now the gene we don't know, the structure we don't know. We don't know the sequences which is responsible for the production of human growth hormone. But what we can find is the RNA, which is actually producing this particular hormone, that is human growth hormone. Now what we can do is, we can take this particular mRNA, that is RNA, from which the protein will be synthesized. Rather going from protein synthesizing, what we can do is, we can reverse the process and we can know the DNA sequence. We can get the DNA sequence, and once we got the DNA sequence, what we can do is, we can analyze it. We can analyze the DNA molecule. And then we can get to know that what is the sequence, what are the genes which is responsible for the production of that particular hormone, which is human growth hormone. Now what we do doing so much of analysis, what we do after analyzing every set of DNA, what we do actually, we keep the information. And genuinely, what we do in normal life, we keep our information, that is books, in a library, right? So here also, we keep the DNA's information in a library called Genomic Library. Now what is a Genomic Library? Genomic Library is a library in which we have stored the information of DNA. We have stored the total genomic structure of any and any organism, we can store the information. That is, what are the sequences are there, what are the genes which is responsible for producing various kinds of products, proteins, etc. We store the information in the genomic library. Yes, definitely we can access. There are some specialized websites by which actually we can access to this genomic library. Though it is not for all, but yes, we have some website like NCBI, for example. So these are the things. Now, like genomic library, there is another library which is known as cDNA library. Now, what is cDNA library? C stands for complementary, and DNA is DNA, that is deoxyribonucleic acid. Now, in cDNA library, what we get is whatever the DNA we have analyzed by using reverse transcriptase, which is a complementary DNA sequence from mRNA or any kind of RNA. What we have produced, the complementary DNA from the RNA, that is cDNA. Now this cDNA analyzed information is stored in this library called cDNA library. Now these are some of the applications and techniques in biotechnology. Now I have some questions for you. The question is, please tell me the various applications for page age, southern hybridization, northern hybridization, western blotting, and reverse transcriptase, genomic library, cDNA library. For these two, what is the use of these libraries? How we can use it and what for? Thank you for watching this video. And if you have any doubts, any query, please DM me in my number which is given into the description. Thank you for today. Bye.